a journey through space and time to discover what's really out there in our universe. We will be talking to experts in the field to find out about upcoming NASA projects, as well as learning more about our very own moon. But before we get to the sky, let's first see what's happening here in our own backyard. Well, bathroom really. Now, most people take showers to get clean, leaving us feeling refreshed and healthy. However, researchers here at CU are finding that a face full of shower water may actually make you sick. Clean water doesn't come easy these days. When you step into your shower, you wouldn't expect to come out dirtier than when you went in, right? Well, a recent study from the University of Colorado at Boulder, led by study author Norman Pace, finds pathogenic bacteria in shower heads. The study began when students started sampling their own, which then led researchers to examine more than 50 shower heads from 9 cities in 7 states, Colorado being one of them. However, not all of the news was bad.
And for the most part, we found environmental bacteria, things you'd expect to see in a water supply. What we did find was Mycobacterium avium, which is a bacterium that for the average person doesn't mean much. It's perfectly safe, but for people who are immunocompromised, they have HIV or a recent organ transplant, it can be dangerous. It's a close relative of Mycobacterium tuberculosis, which causes tuberculosis. So it can cause a respiratory infection that's pretty similar to tuberculosis.
For you and me, the Mycobacteria avium found in some shower heads isn't anything to worry about. About 30% of the shower heads actually carry the avium bacteria. So next time you're in the market for a new shower head, choose a filter or a new metal head. A typical room can contain billions of bacteria, just as the night sky is filled with billions of stars. From billions of bacteria to billions of stars, how about that for a segue? Professor Webb Cash of the Department of Astrophysical and Planetary Sciences and his graduate students wanted to learn more about the nearby Cygnus Loop, a massive star explosion that occurred more than 10,000 years ago. By sending a research rocket 200 miles into space, they were able to learn about the evolution of the galaxy. CU Science Update's GAYLEN CLUTTER visited his lab at CASA, the Center for Astrophysics and Space Astronomy, to find out more about his launch.
In Boulder, the Flatirons get a lot of camera time, but here at CASA, Professor Cash and his students want to take a snapshot of a supernova. Let's see how it happens.
Sounding rockets are very inexpensive, and we take chances that NASA normally doesn't allow.
By taking risks, the team is discovering more science in the process. This is definitely true for their new project, which begins by launching a rocket payload 200 miles into space.
We're going to be looking at something called the Cygnus Loop, which is a explosion, a supernova explosion occurred something like 10,000 years ago in the constellation of Cygnus, so somewhat over 1,000 light years away.
Once Cash and his grad students get the images, they begin to analyze the data.
While the payload is above the atmosphere, it has an attitude control system on it, and it automatically points at a place in the sky that we've chosen in advance, and then it starts collecting individual X-ray photons. But then in the computer, we build that up into a single image, and it's that image that we analyze.
So what exactly can the team learn from these X-rays?
It tells us a lot about the evolution of our galaxy. It affects star formation, it affects the evolution of stars, so it really tells us just how everything works.
It seems that a quick snapshot of a supernova could reveal more than we ever thought possible. This is GAYLEN CLUTTER for CU Science Update.
Here at CU, we are lucky to be partners with NASA, the space agency responsible for the Apollo missions that put men on the moon. They have given a $6 million grant to Professor Jack Burns at the Center for Astrophysics and Space Astronomy for his project called Lunar, or the Lunar University Network for Astrophysical Research. Its goal? To conduct a variety of astronomical observations from the lunar surface. This includes studies of gravity, solar flares, and even Einstein's general theory of relativity. CU Science Update's John Cannelly joined Professor Burns in our studios to discuss his project and whether we'll be going back to the moon anytime soon, or perhaps even to Mars.
So can you tell us a little bit about what the Lunar project is and what are some of the highlights and goals of it?
Sure. The Lunar is one of 7 new centers that was funded this last year by the NASA's Lunar Science Institute, which is located at Ames NASA Center in California. And we're very fortunate because we actually have 3 of the 7 centers right here in Boulder. My center, Lunar, is focused on looking at science from the moon, that is, using the moon as a platform to do astronomical and astrophysical observations of the broader universe. So, for example, looking at the sun and how it produces the radiation that may be harmful to future astronauts, and also looking more distantly into the very early stages of the formation of the universe.
So what are, a big part of it is technology. So what is some of the new technology you hope comes out of the project, and what kind of effect might that have on people today?
Well, some of the technology we're looking at right now, we're working towards building a radio astronomical observatory on the far side of the moon. And we have a design for a new kind of antenna, which is very interesting. It involves putting some what are called dipole antennas, which are like the old TV antennas, but embedding them on some plastic material called polyamide film, and actually rolling that film up into a bundle. And then when the astronauts get to the moon, they simply unroll that film, and you have dozens of antennas that are distributed out in a fairly simple way, very lightweight, and that can be used then to electronically phase the antennas together to observe at high resolution the early universe. So this is a new technology that has not been used before and may have some applications for communications more broadly in the future.
So you said studying the old universe, this is what you call the Dark Ages, correct?
That's right, that's right.
That's another big goal of the Lunar project, is to kind of explore these dark ages, as you call them.
That's right. After the Big Bang began about 14 billion years ago, in the first 400,000 years after the Big Bang, had the first light that was available from the universe, and stars and galaxies began to form. But at a long interval of almost 1 billion years before the stars actually collapsed and their first light was created. So that's what astronomers now call the Dark Ages. We can probe that for the first time with our low-frequency radio telescopes on the lunar far side. That's the theory, but there's been no observations collected to date. So this will be very exciting to be able to do those first observations of that so-called Dark Ages.
Very cool. Last year you published a paper. I believe it was titled, Why Do Only Some Galaxies Clusters Have Cool Cores? Does that kind of discuss what does that kind of discuss?
Yeah, that's looking at a later stage of the formation from the early universe, in which these large objects called clusters of galaxies form. We in the Milky Way are part of a small cluster of galaxies. We and the Andromeda Galaxy and about 30 or 40 others form a small cluster of galaxies. And so one of the purposes of this research was to try to understand how these clusters form and how they heat up. And we used some of the largest supercomputers in the world to be able to do those numerical simulations.
You also sit on NASA's Advisory Council.
Yeah, that's right. I chair the Science Committee for NASA's Advisory Council.
And one of the things you guys discuss is potentially putting people on planets such as Mars, and hopefully in the future. How feasible do you think this is, and how far into the future maybe do you see someone actually being able to stand on Mars?
Well, right now we're studying more of the planetary probes, unmanned probes such as the Mars Science Laboratory, which is slated to be launched in 2011. So we're looking at the instrumentation and the technology to be able to do that. This is the largest spacecraft ever landed on another body, and it's the size of, almost the size of a Volkswagen van, a small minivan. And so that's very pioneering, because many of the technologies to land that spacecraft are going to be needed in the future for human expedition to Mars. A human expedition to Mars is still, in my mind, a good 25 or 30 years off in the future. It's a very risky but potentially high reward mission. It takes a year to get to Mars, And because of the alignment between the Earth and Mars, you have to spend a whole year on the surface before returning and almost another year to get back. So right out of the gate, the first human expedition to Mars will take 3 years. So we need to be ready for that, and that's why we're working to set up some bases and outposts on the moon to first learn how to live and work in an alien, hostile environment, but one that's only 3 days away versus Mars, which is a 3-year mission.
Right, so that's kind of my next question. Do you hope that the Lunar project might be able to help develop ways to get to Mars, or maybe at least create some small stepping stones?
That's the idea. That's exactly the idea. Moon, as we said, the moon is relatively easy to get to. If there's a medical emergency or some other emergency, one can recover from that relatively easily. But the moon, we think now, there's good evidence that there's water that's located in some of the permanently shadowed poles or craters in the poles of the moon. And that makes it like Mars, because Mars also has a lot of water. So one of the things we would like to be able to do with the first human return to the moon is learn how to mine water. Water on the moon is going to be like gold, because that water can be used for spacecraft fuel, to drink, to grow plants, basically everything that you would need. So you don't have to bring all of that water from the Earth.
Right. No, maybe this might sound like a dumb question, but why does it have to be the far side of the moon? Is there any reason for that?
Yeah, the telescopes, the radio telescopes, have to be on the far side, because the far side always faces away from the Earth. The near side that we view is always looking towards the Earth. The Earth is a major source of background noise, both human-made as well as naturally occurring noise. So being on the far side, we're shielded from that radio interference that comes from the Earth at these frequencies less than 100 megahertz, which is sort of the low end of your FM dial.
Okay. So obviously you work here in Boulder at the University of Colorado. What are some of the benefits you see working here at the university and here in Boulder? Are there any major benefits to that?
Well, CU has the largest amount of NASA funding of any university in the country. And so the infrastructure to do space-related work, to build satellites, to work on advanced telescopes, we have the kind of infrastructure and people here that's almost second to none in the nation.
Okay. And just kind of as a last question, take it you've been a scientist your whole life or been interested in it. What's kind of your favorite science memory of all time? Or science biggest discovery you've ever made, or favorite moment being a scientist?
Well, I remember one when I was fairly new into the field. I was first-year graduate student and went observing to a large radio telescope in Green Bank, West Virginia. This was a 300-foot diameter telescope. And I was pretty green, didn't really know what I was doing, but working with a mentor, helping me through and setting up these first observations. And after about an hour or so of working at the telescope, he had me go to the controls, sit down and run this massive telescope all myself. And I felt like I was Captain Kirk on the bridge of the Starship Enterprise, and running this massive beast, looking at objects that were very distant and that no human being had ever viewed before. So that's pretty exciting.
So next time you gaze up at the night sky and you see a full moon, you can now think of the different research going on at CU and know that we are getting closer to discovering more about our vast universe. For CU Science Update, I'm Danielle Brady. Good night.